Hello, welcome. Today let's try to solve another Leetcode problem. 76 minimum window substring. So we are giving two strings s and t, and they have a length of m and n, but we are not giving this m and n. And from this string s and t, we can get the length, of course. So we need to return the minimum window substring of s. So for example, this is a TABC. We want to find a minimum window. So for the minimum window, it is a BANC. So this is a BANC, but we need to return the string, not the length, but it's the same for our calculation. So for solving this problem, I'm gonna use the sliding window technique. So I'm gonna use a two counter sliding window template to solve the problem. First of all, I'm gonna use a 52 times ON to solve it. After that, I'm gonna optimize it to ON because N is 10 to the power of 4 and we have both lowercase and uppercase English letters. This means it can be 52 letters in total, 52 unique letters in total. Yeah, so for the follow-up, could you find an algorithm that runs in OM plus N time? Yeah, so this is what I said. I'm gonna optimize from O52 times N to this OM plus N. So basically, this OM plus N is the length of S and the length of T, and basically it is ON. Yeah. Now let me try to solve it use the brute force. So for the two counter template, I'm gonna define two counters, dt and ds. Yeah, and dt. So the ds will be an empty counter. Because I'm gonna check the S string inside, I'm gonna find a window. I'm gonna find a minimum window. Yeah. So ds would be an empty counter, and dt would be a counter of t. Now I'm gonna prepare the left index L and the result. So for the left index, it would be 0, and the result, I'm gonna use a s plus character. This why I gonna prepare like this? Because according to the question, if we cannot find it, so for this S string, if we cannot find this AA inside this S, we're gonna return an empty string. Yeah, but we want to find the minimum window substring, and for each of the iteration, while I'm check inside the sliding window, I will always check the minimum. So I'm gonna prepare this result as a S character plus this dollar sign. So this means if I didn't find, so the final result would be this. Yeah, if it is this, I'm gonna return an empty string. Otherwise, I will return my result because the result would always be a substring of s plus this dollar sign if I have a result. Otherwise, I'm gonna return empty string. So you will understand it later while I'm writing the code. Now I'm going to enumerate the right index. So for RC, enumerate the string s. So I can update the counter for this character C would be +1. Yeah. Now I'm going to check if this ds is more than and equal to dt. Yeah. So it means I've already found a result. Yeah. So I can update the result. So the result would be the result with with the string s, and inside it would be L index and R index +1. Yeah, why I use the mean with a string? Because I'm gonna use a lambda function, so the k would be equal to the length. So for this function, basically I'm gonna compare with the result with the string s, L to R +1. I'm gonna choose the smaller one. If this is smaller, I'm gonna give this string to the result. But this function basically return a string, not the length. So this is why I have a lambda function k equal to the length. But finally, I'm gonna give this string to the result if it is shorter than this result. Otherwise, it will be the result itself. Yeah. After that, I'm gonna update the sliding window +1. But before that, I need to check the counter. I need to check the counter S. So inside the S, so for this character SL to the left side, to the left side of the window, I'm gonna check this character. So this character would be -1. And after that, the L pointer would be shifted one place to the right side. So this is basically I can find the final result. If everything is okay, I'm gonna return the result. But I need to check this result. If result not equal to S plus the $sign. Otherwise, if it is still the same, I'm gonna return an empty string because this is according to this example. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, but it's pretty slow. It is more than 1 second, and it's 55% of all submissions. But we want to optimize this problem to O(n plus n), because here this is O52 times n. Because for this while check, we're gonna check the hash table. We're gonna check the counter. So inside the counter, there will be 52 lowercase and uppercase English letters. So it will be 52 times n. But we want to optimize to O(n), basically O(n plus m). So what we can do? We're gonna use some extra variables, to solve it easily. So based on this template, we can add some variables. This is also a basic technique for optimizing the hash table with the slightly window problem. If for this problem it is okay, 10 to the power of 5. If it is 10 to the power of 6 or 7, we have to optimize to O(n). And also we have a follow-up question. It means we have to optimize it. Now let's try to optimize. I'm gonna use a count. This count will count the length of the dictionary dt. So from the beginning, the count will be 0. And I'm gonna prepare a length of dt. So this dt length will be the length of the dictionary dt. Why? Because I'm not sure how many characters are inside. If I compare the length of dt, definitely it will be wrong. I have to compare the length of the hash table. This count is the length of the hash table. If my count equals to this dt length, equals to the length of the hash table for this counter t, it means I've already found a result. I can get the result. Now let's try to optimize a little bit. So here it will be the same. Basically for this ds, counter ds, we're gonna update it. Now we need a if check to check this ds for this character c. If this is c equal to dt, the counter of t, it means at least we find a character. For example, this character a. If we find a character, what we're gonna do? So our count will be plus equal to 1. As you can see, we didn't do much change. We only changed this line. So for this line, this means if we find a count, so the count will be plus 1. So if this count equals to the dt length, it means we find a result. So from this technique, we can turn this. We can reduce this 52 operations to just O(1). Exactly O(1). But for here, we don't need to compare the hash table anymore because this is 52. We have to compare the count with this dt length. If the count equals to the dt length, it means we find a result. So we're gonna update this result. It would be the same. And here, it would also be the same. But we need to also update the count because we are not sure we need to update this count or not, but definitely we need a tag. Yeah. So here for this ds for this s counter, so for the character from the left side, gonna reduce 1, and we have to have a tag. So for this ds sl, yeah, if from the left side of the window for this character is less than dt, inside it will be the SL. Yeah. So if this character, while we are checking if the code equal, yeah, we're gonna have a result. Yeah, we're gonna shift the sliding window from the left side, shifted one place to the right. But we also need to check the code. Yeah, if this character inside the DS is less than inside the DT, it means the code should be -1. Yeah, so for example, before they are equals, it's 3 and 3. Yeah, now for this one, if it is less than this character inside the dt, yeah, the count will be -1. It becomes 2, so we'll jump out of this while loop, yeah, and go for the next. So here the count will be -1. Yeah, basically this is the entire code. As you can see, we didn't do much things, only from here, and this is for checking one character, yeah, and for this one is for finding the result, and here is just for updating the counter, updating the count. Yeah, we didn't do much things, only do one condition, another change, and here we update the count. Basically, it's also the same. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, and it's much faster than before. It becomes 0.2 seconds. And the time complexity also becomes ON, because here, even we have a while loop, but basically this is a sliding window, and this while loop only check 2 variables, not the counter anymore, so this is why it is ON. Thank you for watching, see you next time.